Math Mentor May here, coming with a new math topic. Today we are talking about derivatives. All right, derivatives. We are going to focus on the difference rule. Actually, also, I did slide in some rule in there as well. Basically just says, as you're taking the derivative of an entire polynomial, that you take the derivative of every term individually. Let's do a couple examples. 2's a couple, 3's a crowd. All right, so we need to find the derivative of our function f of x. And f of x is equal to negative 26x minus 69. As you see, we have our difference rule function formula at the bottom. So as we are finding the derivative of our function, once again, we then take the derivative of each term individually. So we find the derivative with respect to x, of our first term, which is negative 26x, minus the derivative with respect to x of our second term, which is 69. Let's first talk about our first term. So the derivative with respect to x of negative 26x, if your variable has an exponent with 1, you can just drop that variable and your derivative is just the coefficient. So the derivative that we have is negative 26. And we are going to subtract that from the derivative of 69. So as you see here, we are trying to find the derivative with respect to x of a constant. Constant. Is there any rate of change in a constant? Think about a constant line. Is there any change that can happen? No. And actually, there's no x here anyway. So the derivative of a constant, if you don't know, now you know, is always 0. Always. Always. And negative 26 minus 0 is just negative 26. So the derivative of our function f of x equal to negative 26. Let's do the same thing here when we need to find the derivative of our f of x, which is equal to 52x plus 63. So we find the derivative of f of x, find the derivative of 52x plus the derivative of 63. Let's actually break down that easy trick I talked about. So when we're taking the derivative, we look at our variable's exponent, which is 1, okay? We multiply that by our coefficient. So we have 1 times 52, and then we also subtract 1 from our exponent. 1 times 52 is 52. 1 minus 1 is 0. Anything with an exponent of 0 is just what, kids? It's 1. So we can just rewrite that with 1. And 52 times 1 is just 52. All right? So that's why I was able to just remove that variable from our last example, because it had an exponent of 1. There's not really any much work you got to do. And the more you do your derivative practice, the more you'll see and the faster you'll be able to point out those tricks. And it really does come in handy. All right, now we need to also find the derivative of 63. Once again, 63 is a constant. There is no change that is ever going to happen with a constant. That derivative is always going to be 0. And for our final answer, 52 plus 0 is just 52, okay? So as you see here, our polynomial may look long, may look kind of scary, but when you're finding the derivative, sometimes it just boils down to one little bitty number, all right? Remember your tips, remember your tricks, remember your formulas. Remember, I have the most awesome tutoring services. And remember that you can't be afraid of math. Let math be afraid of you. All right, guys.